This is binary operation. So under this we are going to discuss a closed set. Okay, so we are going to use the idea of what a closed door to define or get an understanding of exactly when do you say a certain set is closed, right? Okay, so let's get started. Now, when exactly do you say a set is closed, right? So if you have been on this channel for some time now, you understand that sometimes I use an idea of a house to replace a set. Is that okay? You use an idea of a house or maybe a room or something of that nature, right? Just to see that we are putting something inside a house, right? That is the idea behind what a set by assumption, right? So now let's limit ourselves to what a house. So when do we say a set is closed, right? So assuming we have a house, there are people inside the house, right? Assuming you have a house and then there are people inside the house. What will happen if you close the main gate, right? Everybody will remain inside. Is that okay? Yes, everybody will remain inside. That is when we say that the house is closed under the operation. So what will be the operation? Of course, I'll use a pure past question to demonstrate that. So let's get a question and see how best we can understand that. So here's the book. I think here's the yeah. So here's the question. Here's the question. They say a binary operation, maybe a delta or triangle, is defined on a set. So that is the set. So that is the house that we are talking about here. So the house is T is equal to 2, 3, 4, and 5. So how many people are in the house? 4 people are in the house, right? By name of 2, 3, 4, and 5. And then they are defined by what? Let's say A delta B. A operation B is equal to 3A plus what? 2B minus AB. Is that okay? So what we are going to do is that maybe the operation is being defined by when you pick the first person, you combine that with the second person, right? How do they combine? How do you combine them together? So that's the most important thing. They say 3 the first one plus or 2 multiplied by the second person and then minus the multiplication of the 2. And they say you should copy and complete this table, right? We are going to copy that and complete it very soon. So and then they say to show that whether or not C is closed under the operation. Is that okay? And then finally you should evaluate that. So let's dive into the solution. Let's see how best we can explain that. So here you go. Here you go. Here's the question. So here's the table. Is that okay? So they say we should determine whether we copy. First of all, they say we should copy and complete the table, right? We are going to copy. So this is the copy, right? This operation, okay. This is how the operation is being defined. So A delta B, right? A delta B. The first person. How can we combine two people in our house? So how many people are in the house? First of all, there are only 4 people, right? We have 2, 3, 5, 4, and 5. And then we want to combine them together. Let's say this is a marriage, right? Okay, so the first person will get married to the second person, something of that nature, just for understanding purpose, right? So we are 4 in the house. So the first person, we want to combine them by this operation. So the most important thing is how the operation is being defined. They say for you guys to be together, then you pick the 3 multiplied by the first person plus 1, 2 multiplied by the second person, and then minus the multiplication of the 2. Of course, addition and multiplication, we know them already, right? The most important thing here is how to define this operation, right? So your focus should be on how the operation is being defined. What I mean by the operation is how to combine two things. Is that okay? So pick the first person and so on and so forth. Now let's complete the table. Let's complete the table. So let's get to that. Now look at what is happening. Then this is the table. Suppose you are not giving a table, you have to draw your own table. Is that okay? In some questions it happens like that. So you have to draw your own table. So now let's say this is the first person, and then you want to combine that with this. This is the second person. So the blue one is the first person, and this the red people are the second people. Is that okay? Now let's say 2 is the first one, and then delta 2. Can you see that? So we want to combine this guy and this guy by this operation. That is the law. This is the law that binds them together. right? How is the law being defined? The law defines that when you pick the first person and the second person, then 3 multiplied by the first person, so 3 multiplied by the first person. Who is the first person? This is 2, and then plus what? 2 multiplied by the second person. The second person is what? It's also 2, and then minus what? 3 minus what? The first person by what? The second person. What is the first person? That is 2 multiplied by what? The second person. Is that okay? So this thing, we know them. This one will give me 6, this one will give me a plus 4, and then this one will give you what? Minus 4, right? So this will go is equal to 6. Is that okay? So because this and guy, this and that will go, or maybe 10 minus 4, that will give me 40. Alright, sorry. And then that will give me what? 60. So that is why we got a 6 in this side. Is that okay? So maybe let me do the second one, then you can see better. So the same person is being combined with this guy. Is that okay? The same person here being combined with that guy. So that will be 2. Let me take this guy out. So that will be 2, 3. Obviously, we are going to combine this and that, right, by this operation or by this law. So how are they combined? So the first person is 2, the second person is 3, and then 2. They say you should combine them by multiply the first person by 3. So 3 multiplied by the first person, which is 2 here. Can you see that? 2, and then plus 2 multiplied by the second person, right? The second person is 3. So the second person is 3 minus what? The first person multiplied by the second person. So the first person here is 2 multiplied by what? The second person, that is 3. Okay. So when you do this calculation, you can see that here is 6 plus here should be 6 minus 6. Is that okay? The answer is 6, right? So that is how we got another 60. So the same way you have to go about it and to complete your table. Is that okay? So of course we are giving you a table. Maybe you can go back and check the table very well. Just scroll the video back and see what is happening. So these are the empty spaces that we are having, right? You just need to compare that the same way. So it's 3 being combined with 2, right, by this operation. So 3 operation 2. When you do the calculation of just I did, you just have you arrive at the answer to be 7. So just fill in the spaces, right? So perfectly. If you have any problem, just comment down below and then we are ready to help you. Now let's get to the main issue of the day, which is they say you should verify whether the set is closed, right? That is what they are asking us to do. They say you should verify whether the set is closed. So you want to check that. Now one thing is that you have to know the tool to use. So the tool here is, when do you say a set is closed? So as I say earlier on, a set is closed. You may write this thing somewhere. Set. So our house, how many people are in the house? 4 people are in the house. So the set is closed. It's closed. When we combine 2 people, right, we get the same person in the house. Did you get that? Not so obvious. Let's say you people are in the house, 4 of you are in your house, and then the main gate is being closed, or maybe you are in your room, the main door is being closed. What will happen? You don't care. No matter how we combine 2 of you together, then you must get the third person inside the room, right? Because you are not adding anybody in addition to you, right? Let's see this picture. So you are here, and then another person is here, right? And then another person is here. Is that okay? So how many of you? 3 of you are in the house. Is that okay? And the door is closed, right? The door is closed. We don't care how 2 of you will combine together. Then whatever you get must be inside that room or the house. Is that okay? And that is when we say the set is closed. So when you get everybody inside the house after combining, then we say that that set is closed under the law. The law here is the operation. Are you getting that? So maybe let me explain that once again. So let's use the technical term. The technical term says that we say a set is closed under the operation. If you perform any calculation or any operation, the answer that you get must be part of the set. So what I mean by that is that here we are having four people in the house. So namely 2, 3, 4 and 5. Is that okay? So no matter what we do or how best we can combine them with the operation or the law being given to us, the answer that we get must be part of these 4 guys. Anything beyond that, then we can say that the set is not closed. Is that okay? So let's check whether everybody, all the answers that we get are part of what these guys. So from the table you can see that we have only 2, 3, 4, and 5 people in our house, right? So anything beyond that, we can say that the set is not closed, right? Of course, you can see that we are having 6 here, 7 here, 8 here, 9 here, 6, right? And then 0, right? All these guys tells you that that set is not closed. Is that okay? The set is not closed. Are you getting the picture? Right? So anybody that maybe after combining, the answer that you get has to be part of the house. So you guys are only 4, right? So we can say that just one person. We don't want any strange person in our house. So any strange person that comes in our house, it means that our set or our house is not closed. We can only be close if that person is a family member. So what I mean by the family member is of this guy, we are only 4 in our family. So okay, no matter how we combine by this law, we are still a family member, right? So no matter how you combine 2 of you, we are still a family member. So the answers that we get has to be the family member, one of the family members. Is that okay? So anything beyond the family member tells me that our family is not close, right? The set is not close in that case. So of course, 6 is not part of our family, 7 is not part of our family, 8 is not part of our family, and so on and so forth. Is that okay? Since one person is not part of our family, after combining, then we say that the set is not closed. Just very as simple as that. Is that okay? So you can write your own English, how best you understand it. You can say that since so and so, maybe let's say 7 or 5, anyone, right? 7 or 5, or you can even decide to list all of them, right? Since those guys are not part of all, right? Since you just say since 7 that is are not part of what? T. This is our family, right? T. Then then what? T is not closed. Is that okay? This is just a simple definition of a closed, right? Because we want everybody to be a family member. If we are not part of, after combining what we get, we are not part of the family member, then we can say that T is not closed. Is that okay? Very, very simple. So if you've enjoyed the video, don't forget to give us a like and then subscribe to our YouTube channel for more details. Thanks for watching.